In this video, let's see the topic on stability analysis of retaining wall. First of all, myself, B. Chelapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So, first one is stability analysis. It is nothing but analyzing the stability of a soil by modifying the properties of soil or any improving the engineering properties and for improving their performance, etc. The main objective for stability analysis is to increase the strength or stability of soil or to reduce the construction cost, etc. So there are various methods of soil stabilization: mechanical stabilization, cement stabilization, lime stabilization, bitumen stabilization, chemical stabilization, stabilization by heating, and electrical stabilization. First one is mechanical stabilizations. In mechanical stabilization involves two operations: changing the composition of soil or densification of soil. Changing the composition of soil means it is done by addition or removal of certain constituents. In densification or compaction means the compaction process are carried out so that the pores in the soils are comes close together and packed, and finally densified structures are to be made. So further that the failure of the retaining wall are to be avoided. Next one, cement stabilization. In cement stabilization, the soil cement and its influencing factor. So from the heading you can understand that stabilization of the soil by cement. So that soil cement is called as soil cement. Here the cementing action is believed as a reaction of chemical reaction of cement. Normally we know that soil is a siliceous material. When it is react with cement, the binding actions are to be act only in coarse grained soils only. But in fine grained soils, they are combined with natural soils, that is natural pollution. So the important factors affecting the soil cements are depends upon the nature of the soil, cement content, condition of mixing, compaction, curing and admixtures, etc. So next one is construction method. The normal construction sequence, already our sequence is shaping this grade, pulverizing the soil, addition of mixing cement, addition and mixing of water, compacting, finishing, curing and adding weathering course. There are three methods for carried out in this operation, that is mix in place method, traveling plant method and stationary plant method. Mix in place method means the mixes are done at the place of a factory. Traveling plant method means the cement mixes are done at the factory site and comes to the construction train. Next one is stationary plant method. Stationary plant method means the plant at stationary at in construction site. Next one is lime stabilization. Lime can be used alone or with a combinations of cement, bitumens or fly ash, etc. Normally, the sandy soils can be stabilized with this combination. So, this type of stabilization is used for stabilizing the road bases, subgraders, etc. So, there are two main type of chemical reaction occur. First one is alteration in nature of observed layer. Next, cementing or pozzolanic action on the next one is bitumen stabilization. So bitumen means asphalt or tar are used as a bituminous material for stabilization of soil, and it is generally used for pavement constructions. So bitumen materials, when it is added to soil, it impact cohesions or binding action. So thus either the binding action, the waterproofing actions or both the action may be utilized by this stabilization. So depending upon their action and nature of soil, bitumen stabilization is classified into following four types: sand bitumen, soil bitumen, waterproof mechanical stabilization, and oiled earth. So next one is chemical stabilization. So chemical stabilization means the stabilization of soil are done by using chemical. So only the chemicals which are commonly used for stabilizing moisture in soil and cementation particles are described as calcium chloride, sodium chloride, and sodium silicate. And next one is stabilization done by heating. During heating, a fine grained soil at temperature of order of 400 to 600 degrees Celsius causes irreversible change in a clay mineral. So soil becomes non-plastic, less water sensitive, and non-expansive. Therefore, the clay clods gets converted into aggregate, and again it is baked in a kiln, then or a kiln or in furnace. The artificial aggregates are also produced and can be used for mechanical stabilization process. Next one is electrical stabilization. So by using a current passes through them, we are stabilizing the soil. Here the stability or shear strength of fine grained soil can be increased by draining them with a passage of direct current through them. This process is called as electroosmosis. So electrical drainage is accompanied by electrochemical composition of electrode and deposition of metal salt in the soil pores. So the structure of the soil may get changed. So resulting cemmenting of soils due to this reaction is called as electrochemical hardening, and for this purpose is used for anodes are mainly made up with aluminium is recommended. Next one, different mode of failure of retaining wall. So there are three failures. One is failure against sliding, failure against overturning, failure against bearing capacity. So first one, failure against sliding. In failure against sliding, the soil in front of the retaining wall provides the pressure such as active and passive resistance. So the wall tends to slide. Sometimes use of key beneath the base provides additional sliding stability. So factor of safety is ratio of sum of resisting force to sum of driving force. So factor of safety against sliding should be at least 1.5 for sandy soil and 2 for clay soil. Second one is failure against overturning. Due to pressure, the retaining walls tends to overturn. So here factor of safety is calculated by ratio of sum of resisting force to sum of overturning force. So here overturning is normally considered with respect at toe, and factor of safety should be kept 1.5 for sandy soil and 2 clay soil. Next one is failure against bearing capacity. So factor of safety is calculated by allowable bearing pressure divided by maximum contact pressure. So normally vertical load causes uniform contact pressure at the base. So overturning moment causes compressive pressure at toe and tensile pressure at heel. So sum of contact pressure is maximum at toe. Therefore, factor of safety against bearing capacity should be at least 2.4 for sandy soil and 3.0 for clay soil. So in this video, we see about the stabilization method of retaining wall and different modes of failure. Thank you.